Hello, everyone, and welcome to Talk Nerdy. It is Monday, July 11th, and I'm your host, Cara Santa Maria. This week, I want to give a shout out to those of you who made Talk Nerdy possible, including those of you who visited www.patreon.com/talknerdy and pledged your support of the show. At the highest level, I want to thank Phil T-Bear and Timothy Glover, and additional supporters include Rod Adams, Charles Payette, Jafe, The Honorable Husband, Gabriel Felipe Jaramillo Gonzalez, Ken Pfeiffer, Brian Holden, and Jeffrey Sewell. And you know what, guys? There are literally like hundreds more of you. I want to thank all of you from the bottom of my heart for making Talk Nerdy possible and for continuing to allow it to be 100% free to download. You know what? I'm really excited about my guest this week, so I'm ready to dive right in. She has the coolest title. She's the Deputy Director of Science for Communication at NASA headquarters. Without any further ado, here she is, Dr. Michelle Thaller. Michelle, thank you so much for taking the time to sit down and chat with me remotely across the country today.
Hey, anything that is nerdy in the title, I'm there. We're very happy to be here.
I'm so excited. So I literally just got back from a camping trip like a few minutes ago. So I apologize in advance if my voice is a little scratchy and my head is not quite, my processing speed isn't quite up to snuff today. Been sleeping on the ground, but we had such a wonderful time. Drove up about 5 hours in California and brought the telescope so that we could do some stargazing. And it was just lovely. How often in your job working for NASA do you actually get to sit back and look up at the stars?
Oh, hardly it ever in my job. You know, I just took my husband to Botswana for his 60th birthday, and I absolutely adore the southern sky. It just gives me fits. I mean, I was in Chile about a year ago, up by Alma, so very very high altitude, very dry desert, and there was a night there. It was a moonless night. And somebody pointed out that we actually had these faint little shadows that we were casting. And it was a shadow from the Milky Way.
No.
The Milky Way was so bright that there was a shadow. So I used to be a research astronomer basically right after I got my doctorate. I did a lot of research at different telescopes. But then I sort of got into the space telescopes end of things. And unfortunately there you don't get to go to the telescope.
Yeah, but you get to tell the stories. So maybe for people who aren't familiar, let us know what is your job title at NASA?
Well, at the moment, it's Deputy Director of Science for Communication. So there's a number of people that are at headquarters and they have different roles as scientists. And I have kind of a unique one. I mean, there really hasn't been anybody in this job before. It's one of the jobs you have to make for yourself
Mm-hmm.
where, you say, okay, well, I'm a scientist, but I really, really want to focus on how we do communication. So that's sort of a job title I wrote myself.
And so it's very different than what we think of as traditional publicity. You know, I think a lot of people who read The Martian and then watch the movie and they think of this Kristen Wiig character, right? This
Yeah.
person who is there to kind of communicate to the public what's going on at NASA, but she's a full publicist. She doesn't seem to have any scientific training whatsoever.
That's right. And we have people whose expertise is more like that at
Mm-hmm.
NASA. So we have people that know about social media or they know about traditional news media, press releases, all of that. They know about managing the message, making sure that we have the consistency and everything is correct and, we're doing everything right politically. And that's actually not me. That I do have this rather odd position of being the person that kind of provides the narrative for the science. And most of the job, like everything else, is planning and budgets and begging for money and trying to figure out metrics and are we doing the right thing? But very occasionally, like last weekend with Juno, I get a chance to actually tell the story, and that is my absolute favorite part of the job.
I think it's so wonderful, too, that the administration at NASA understands why it's so necessary. I think that one thing that NASA has always done such a wonderful job of is just getting the fact that science can't exist in a vacuum, and that if the public doesn't appreciate the science, and that if the public isn't aware of the stories behind the science, that they're not going to be interested in contributing funding. They're not going to be interested in, getting I think, emotionally behind a lot of the missions. And NASA, more than I feel like any other public institution, definitely more than most universities and most other organizations that actively do science, really understand that. They were just decades ahead when it comes to science communication.
Well, there's certainly no other federal agency that has the type of public footprint that we do. And that is very deliberate. That doesn't just happen. We
Hmm.
have a staff of people. It's a big investment. I occasionally I get comments online. People will say, but remember, you guys are using, tax money to do this. And I think that what people don't understand is that that's never far out of our mind. We very
Yeah.
much understand how lucky we are to be exploring the universe and the fact that, yeah, I mean, that this is funded by public money. And that's something that, there's no option here. We have to take the public along. We have to make them feel invested. And yes, part of it is to get more funding, to get the public support, but that's not why I'm doing it. That's not what I think about. I mean,
Hmm.
I really, I mean, this sounds a bit, in some ways, sort of an arrogant scientist thing to say, but I really do think people's lives are made better by this. And that's why I want them along with us for that.
Absolutely. And since you're at headquarters, you're in DC, correct?
That's right. Yeah.
Since you're there, you get to communicate science from across the different NASA campuses. So, we've got a lot of really interesting stuff that happens all over the spectrum. And Juno is something that I think was very close to the hearts and minds of individuals out here in California, because there was so much great stuff happening at JPL, and it really reminds us, I think, of the landing of Curiosity. I feel like it had a taste of that sort of excitement, especially in the social world.
It did. I mean, obviously the Curiosity landing was even more dramatic.
Hmm.
Putting something into orbit around Jupiter is amazingly cool, and of course there are difficulties, but it's not anything like landing something with a sky crane. And
Yeah.
so, I mean, the night Juno went into orbit around Jupiter was a little bit of. In some ways, it wasn't quite as exciting as Curiosity, but I have to say, my anxiety level was nothing like it was for Curiosity. When I first saw the plans for how they were going to land Curiosity, and then it has to, get the radar, it's got to get the right distance, and then we could take the sky crane has to bring it down, then we detach, we got to fly away. I just looked at that and said, well, what the hell? And I mean, I understand they're brilliant engineers who thought we could do this, but that was one of those things where I'm not sure I would have put good money on it actually working. And when it did, and I realized the magnitude of the accomplishment, that was a moment in my life where I sort of hardly remember it because I was screaming and jumping up and I was out of control. I mean, my mind turned off and I was
Hmm.
just screaming and jumping up and down. And, that doesn't happen all that often in your life where you just get taken away. And the night that for Juno on July 4th was a flavor of that, was a taste of that. I definitely felt the joy, but I'm also really glad I wasn't as worried as I was the night Curiosity landed.
I'll tell you what, when Curiosity landed, at the time I was doing science reporting for the Huffington Post, and I was lucky enough to have an interview with Adam Steltzner, who was
Right.
the engineer, of course, in charge of entry, descent,
Yep.
and
Yep.
landing. So all the crazy sky crane stuff. And he was so confident when I interviewed him. And I was so like, okay. It was after the publication of the 7 Minutes of Terror video that
Yeah.
was so
Yeah.
exciting. And it's true. I think in many ways it was my generation's moon landing, because not, not until that point did I experience people my age, people in their 20s and 30s, tuning into NASA TV. People really watching with bated breath to see exactly what was going to happen, and tears of joy, celebrations, cry. I mean, the Twitter storm that occurred that night was such a testament to the fact that kind of all is not lost when it comes to excitement about science in America. Sometimes we can get a little bit disheartened, I think. We can get a little bit cynical about the American view of science and scientific inquiry. But I think that the Curiosity landing really reinforced, to me at least, that the public cares. They really do. They just have to be communicated to in the appropriate way.
It's amazing how much things have changed. I mean, so Curiosity landed, what, about 2.5 years ago, and I forget exactly what our Twitter footprint that was that night, but it was funny. It was nothing like it was for New Horizons when we
Uh-huh.
when we flew by Pluto. For the 1 week surrounding the Pluto flyby, our Twitter footprint was 12 billion, and
No,
and
that's
that was
insane.
so it actually just shows you, how social media has changed. That
Completely.
even 2.5 years ago, you just didn't get the numbers on social media you do now.
Yeah, and just really I think the power of imagery. There's just something about being able to see what we couldn't see before and seeing this resolving power. I mean, getting back those images of Pluto and going like, "Oh my God, that's what it actually looks like." It's not just
Yeah.
this pixelated, rocky, icy thing that none of us could really put our fingers on. That was just so stunning.
We'd never seen that world before. I mean, that was a whole place. I mean, people knew the name, people knew about it, but nobody had ever seen it. But even something like Curiosity, I mean, we routinely now get these beautiful panoramas back of
Mhm.
Mars. In fact, they're so good that at JPL they use Microsoft HoloLens virtual reality glasses to actually put on the science team. They actually just put these headsets on, and the science team can walk around where the rover is,
That's
and they can
incredible.
and they can say it's like, oh, let's go over this hill, let's look at that rock, because it actually just makes it an easier way to do operations when all the science team can just see the same images at once. But the thing that I just have to stop people and say, just stop a moment. This is not Nevada. This is not somewhere in Arizona. This is on another planet. And we have a car-sized nuclear powered laser shooting robot. And, you know, there are people every morning who are going into work, putting on their HoloLens headsets and figuring out, what the science plan is for the day. And it's not, this is on another freaking planet. And I don't think people really get how amazing that is.
And I think a big part of that is taking the time to just stop and look up. And this is something I had Summer Ash. She's an astronomer who runs outreach at Columbia University. I had her on the podcast recently, and it was so amazing hearing her talk about the fact that even in the middle of New York City, you can stop and look up and you can see Jupiter.
Hmm.
And
You,
there's
you
a
can see the
chance
moon.
you can
Just
see
look
the
at the moon.
moon, and
Yeah.
there's a chance that you can see Mars, even in a city with so much light pollution. Here in Los Angeles, I can always spot Mars. It's so obvious when you stop and look up. And I remember when we were camping, one of the girls that was with us made a joke. We pointed out Mars when the sun first set. And she made a joke and kind of waved and said, "Hi, hello, robots." And another girl who was with us, who is another science communicator, said, "Let's stop and think about the fact that that is a planet that is entirely populated by robots."
As far as we know, I'm
Exactly.
still holding out for the microbes. I'm totally holding out for the Martian microbes.
And I mean, now that we have a good idea about the water content, there's a chance. There's a real
Well,
chance.
yeah, there's more than a chance. I mean, I think that, obviously it's nothing that we've found yet or we've proven yet. But when you think about how much life is in the rock here, is in the regolith, all of these very, very extreme, microscopic bacteria that actually live
Mm.
down in the rocks, in some cases miles down. Um, it just seems to me that there's, if life started here, why not on Mars? And it could easily have survived even the catastrophic climate change that Mars went through. So I'm really hoping by the end of my lifetime we have a solid example of an entirely different kind of life.
Ugh, how incredible that we get to be alive during a time when so much knowledge is uncovered because of the tools that we have, because of the amount of processing power that we have that nobody else has had access to in any of the, millennia leading up to now, the incredible discoveries we get to be privy to. And I think this Juno flyby really fits in that sort of bucket. So I'd love to take a few minutes to chat about that. Goodness. I guess maybe we can start with the quick and dirty of what actually happened just 6 days ago now.
Well, about 5 years ago, you pretty much exactly. It was in August 2011. We launched the Juno spacecraft. It took it, a little less than 5 years to get out there. And yes, on July 4th, and that was just a coincidence. I mean, we didn't pick the exact moment. We had a couple days of launch window, could have gone off at any time in that launch window, but it just so happened that it got there on July 4th. And it fired its main engine and slowed itself down and allowed itself to be captured by Jupiter's gravity in the sense that it now is in orbit around Jupiter. And we hope it'll survive for about another 20 months. So yeah, that was the night that we went into orbit around Jupiter.
And what is the purpose, or I should say, the ultimate goal of having this? Is it a probe? This probe orbiting Jupiter?
Well, there's no scientific question that exists as this isolated little thing. I mean, we're not stamp collectors. No offense to stamp collectors, in the sense that we're just trying to like see every planet or characterize or I mean, just you don't get information for no reason other than hey, it's cool. Well, we're around Jupiter. In the case of Jupiter, there are so many questions about how did our solar system form? And what does it tell us about the other solar systems we're now seeing around other stars? And Jupiter appears to be really, really key because it's so massive. Its mass is more than twice all the other planets combined. So when we were forming planets early in the solar system 4.5 billion years ago, Jupiter really sucked up most of the material that was forming planets. And we we thought we understood fairly well. Like when I was in college, before we actually discovered exoplanets, planets in other solar systems, we
Mhm.
noticed that there were lots of little rocky planets that were close to the sun. And then when you got farther out, Jupiter, Saturn, Uranus, Neptune, there were these big gassy planets. That made sense because the sun would have blown all the lighter material, all the methane and the water and the ices out to the outer solar system. So that it made sense, right? I mean, we thought we kind of got it.
Yeah.
And then like the very first solar system we find outside ours, there's a planet like 8 times the size of Jupiter inside the orbit of Mercury. It's just like, oh hell! I mean, that's not what we thought was going to happen. So now we suspect that Jupiter did not form where it is now. It may have formed farther out. We think it may have come in as far as the orbit of Mars. That's actually one of the reasons Mars is so small. It only has a tenth the mass of the Earth because Jupiter kind of ate its lunch when things were
Wow.
forming. And there's all of this mysterious record inside Jupiter about what happened 4.5 billion years ago when the planets were starting to form. And we don't know about the interior very much. We don't know if it has a solid core. We don't know whether it formed first or whether it formed later or took a long time to form. I mentioned we don't know how it's moved around. So understanding Jupiter is going to help us understand not only our own solar system's formation, but it's going to help us interpret all these other hundreds and thousands of other solar systems that we're studying now.
And what are some of the ways that we will be able to understand Jupiter? What are some of the scientific instruments that are on board Juno that are going to help send back data?
It's got this whole suite of science instruments. So, I mean, one of the things that I'm really excited about, it sounds a little technical. I'm excited about the microwave radiometer. Um, Jupiter is actually still forming. It has not completely formed. It's still crushing itself together under the force of gravity. And as it does that, it releases heat.
Mhm.
And that means that the farther down into the interior you go, the clouds get hotter and hotter. And we've tuned this microwave detector to be able to actually look down hundreds of miles into the clouds. We hope it's going to get down like to about 500 miles in. And it's going to, these different wavelengths of microwaves are going to sample different layers of Jupiter. Well, what are the wind speeds? How far down does the red spot go? What is the interior structure like, at least 500 miles into the clouds? And then for deeper than that, where we're going to be studying its magnetic field, that'll have clues about what's going on even deeper. And then this is just kind of clever. So the very, very central core, thousands of miles down, but beneath the clouds, beneath a huge sea of liquid hydrogen,
Mhm.
there may or may not be the solid little planet. And did Jupiter form as a little rocky planet and then accumulated a big atmosphere, or is that not right? Did it form more like a star? In which case, it maybe doesn't have a solid core. And the only way that we're sensing that is by the gravitational field. That every time Juno does one of these super close passes, it goes careening over the clouds at an altitude of about 2,600 miles. And as it does so, each dive, one after the other, there'll be a slight bumpiness to the gravity field,
Hmm.
which will, over time, help us actually sample what the deep interior core is, all the way down to the middle. And that'll tell us a lot about Jupiter right there. Just that gravity.
I had no idea that that was even an idea. I think I always thought of Jupiter as this big, it's a gas giant. That's how
Yeah.
we always worded it. And I just assumed that if you had, the most insane spacecraft ever that had the most insane shielding ever, that you could just fly right through it. I never even thought about the potential for there to be rocky matter in the core.
Well, it's funny. It's a bit of a misnomer. I mean, none of the gas giants are actually made of gas.
Uh
I
huh.
mean, I mean, all of them. So I mean, all of them, Jupiter, Saturn, Uranus, and Neptune, get very dense very quickly, and they're mostly liquid.
Mm.
So, I mean, you go down just a couple hundreds of miles into Jupiter's atmosphere. And I mean, for a little bit of calibration, I mean, Jupiter, the diameter is about 12 times the diameter of Earth. So a couple hundred miles down is just a little tiny bit into Jupiter. Already you get to crushing pressures and temperatures.
Wow.
Temperatures that are in the thousands of degrees. Atmospheric pressure similar to what you would find on Venus, something that would just crush you flat. And then in the case of Jupiter, it very quickly becomes liquid hydrogen. And then only about a third of the way down into the interior, we think it becomes, this is kind of weird, liquid metallic hydrogen. That when you take hydrogen and you super compress it, high temperatures, super compression, you can actually force the atoms to make metallic bonds, and you actually get metallic hydrogen.
Wow.
So, and we think that's true of Saturn. It may not be so much true of Uranus and Neptune. Those are probably more just liquid, but not so much metallic. But Jupiter's mostly metal.
That's so cool. And
Yeah, really
Jupiter,
hot metal.
really, really hot metal. And
Yeah.
Jupiter actually, speaking of hot metal, I think I've mentioned this on the show before. I once had the opportunity to interview Don Pettit when he was on the ISS, and I asked him what space smells like. I had sourced a bunch of
Ah,
questions for my listeners. I was like, what is the smell of space? And he said, when you're on a spacewalk, obviously you can't smell anything because you're in your suit. But sometimes when you're just in the airlock after you've closed the outer doors, but you haven't closed the inner doors, you can smell this hot metal smell. And I think that might be what space smells like.
it's funny, in the interstellar medium, in the gas between the stars, we find all kinds of molecules. But some of the ones that are prevalent are these things called polycyclic aromatic hydrocarbons, which are
Mm.
actually the same thing as burnt toast. And we also find the same sort of compounds. Again, these are organic molecules that are the same things in mothballs. And
Oh,
we
funny.
we find alcohols. I mean, we find all kinds of kind of stinky, sooty.
Hmm.
Really, I mean, obviously, space is so sparse that the human nose, like, you'd be dead for one thing, and the human nose could detect it. But if you actually could smell it, it would smell like burnt toast and mothballs and alcohol and formaldehyde. We found formaldehyde up there.
That's amazing. That's not very pleasant, is
Yeah,
it?
that's kind of neat though. It's
It
sort
is
of
fascinating,
yeah.
actually. And
It's
and Jupiter actually, you mentioned that like Saturn, it has this kind of liquid potentially core, but maybe there's actually a rocky core as
yeah.
well.
Mhm.
Jupiter also has rings, doesn't it? And we never talk about those rings of Jupiter.
Well, we were certainly thinking about them the night that Juno went into orbit, because we were
Hmm.
we were really sort of hoping that we didn't have any trouble with the rings.
That you didn't crash into them?
Well, yeah, exactly. So the rings are very, very sparse. I mean, they're nothing like Saturn's rings. I mean, they weren't even discovered until we actually went out to Jupiter,
Hmm.
and that was the only time we could see them. And they're not very well characterized. They're very difficult to see. And so we're not really sure how far down towards the planet they extend. Now, we were pretty sure. I mean, that there've been other. Galileo was orbiting Jupiter for a while, the Galileo mission, but there was a risk as Juno went down towards Jupiter, that we could have hit particles from the ring. And even tiny little particles, we were traveling at tremendous speeds. And even just a little piece of dust in the wrong place could have been bad. So we were happy that didn't happen.
Oh, definitely. I mean, I know that there's always the fear just on the ISS, anytime that there's a mission, that like the tiniest little speck of dust, when you're
Sure.
going that fast, can have these horrible implications.
Oh yeah, yeah.
So, what about the moons around Jupiter? Jupiter has a lot of moons, doesn't it?
Has over 60. Yeah, and I would imagine there's a chance we might discover more. You never know when more will be discovered. Some of them are so far out that they're
Hmm.
actually quite hard to see. But it has these four whopping huge ones that were some of the first things that Galileo ever saw with a telescope. And I think again, people don't really understand the size and the importance of these. Ganymede, which is the largest moon in the solar system, is very close to the size of the planet Mars.
Wow.
So, I mean, these things would be planets if they weren't around something bigger.
Hmm.
And so you've got Io, which is the most volcanically active body in the solar system, Europa, which has this vast under ice ocean, this warm saltwater ocean that we think has organic chemistry going on. And then you've got Callisto and Ganymede, and both of those have the potential to have a lot of water underneath their icy shells. There's some controversy because this is a very much of a remote sensing measurement, but the Hubble Space Telescope thinks that by observing the auroras, the northern and southern lights on Ganymede, by looking at how the auroras move over the surface, they think it must be actually the electricity must be traveling through about a 60-mile deep conducting ocean, so 60 miles of salt water.
Wow.
And if that's true, that would mean that Ganymede has by far the most amount of liquid water in the solar system.
And Ganymede, you mentioned it's the largest of all of those Galilean moons, but it does seem like we often turn our attentions towards Europa. Is that because Europa was the first moon in which we knew or in which we had good evidence to support the idea that there is a liquid water ocean?
Well, certainly. I mean, Europa captures our imagination because when first Voyager and then Galileo went by, the measurements, especially of the magnetic field, pretty much confirmed that there had to be a lot of liquid water, far more than the Earth has. And so that was the first place where we realized, the Earth is not very special. I mean, we're special in the sense that we have liquid water on the surface, but we don't have the most liquid water. And the cracks, when you look at the color of the ice coming up in the cracks, there's this sort of rusty color that we think is due to salt and possibly organics. And so I think, Europa really captured our imagination. And actually, in both the cases of Callisto and Ganymede, if there's water there, it has to be probably very far under the surface. So Europa is still a place where the water is much more accessible. We're not exactly sure how thick the ice is. It could be tens of miles. It could be hundreds of miles. But there's again the Hubble Space Telescope appears to have some evidence that some bits of it are actually venting water vapor.
Wow.
So there may be it's a little bit of a comparison to the moon of Saturn called Enceladus, where the water is actually flying out of the cracks. In the case of Enceladus, the water is just flying out. In the case of Europa, there may be places where something similar is going on.
Hmm. I noticed recently, I think many of the people who listen to this podcast and who potentially follow some of the social media that I do and a lot of the science communicators in my network, we've been seeing this image that was released of Jupiter, a Hubble image. I'm assuming it's a composite image of data collected by Hubble of this insane aurora on
Oh
Jupiter's
yeah,
North Pole.
they're so beautiful. You're right. Yeah, that is a composite image. There's an image in visible light taken by Hubble of
Mm.
the cloud tops and the colors of Jupiter. And look, sorry, that blows me away. I mean, the Hubble Space Telescope is here in Earth orbit, and it takes these absolutely freaking beautiful pictures
Oh,
of,
it's
of
insane.
yeah. I mean, I
I'm
mean,
so glad it got 5 more years extended onto its life because I can't wait to see what else it gives us.
those pictures of Jupiter are lovely. And you're right. So the auroras are taken in ultraviolet light, so it's a different filter,
Hmm.
and you can just see these huge changeable dancing. They actually released a movie of the auroras. And in the case of Jupiter, one of the things that's so amazing about the auroras is that there are these footprints, they call them, where these big tubes of electrical flux connect Jupiter with its major moons, Io, Callisto, Ganymede. And you can actually see these little hot spots in the aurora follow the moons as they orbit around Jupiter.
Wow.
And like I said, I mean, this possible detection of water underneath the surface of Ganymede, that all comes from observing the auroras. So I'm sure that as Juno flies directly over the poles, right above the auroras, we're going to get this incredible detail. And I would imagine we're going to find out things about how the entire system magnetically and electrically works together.
Is Juno out? Juno.
Juno.
Juno,
Yes.
although yes, although she is female Juno,
Absolutely.
is Juno outfitted with really strong, cameras to take images in the visible light spectrum? Are we going to be getting, the same kinds of beautiful images with a higher resolving power as we saw, for example, when Cassini flew by?
Well, this is something that I'm kind of waiting to see exactly what the images look like myself.
Mm-hmm.
When it comes to observing things like the auroras, we actually do have both UV and ultraviolet instruments that are specially tuned to the radiation from the auroras. The only visible light camera is one that was put on, interestingly enough, for public involvement.
Oh, cool.
Yeah, it's called JunoCam. And JunoCam is not part of the main science goals of Juno.
Mm-hmm.
But I think someone wisely said, if we're going all the way out to Jupiter, we'd probably better bring a visible light camera so people can really feel like they're out there and be involved. And so JunoCam is, because of the proximity, it's going to get so close to Jupiter, JunoCam should take the highest resolution images of the clouds ever taken.
Wow.
Now, what I don't know is exactly what those images will look like. I mean, it's not our very best high resolution optical camera. It's
Yeah.
not. It's a smaller instrument. But I'm hoping they'll be spectacular. I really am.
And the idea that that's there as a public facing project, is there citizen science involved?
Well, there's certainly citizen involvement.
Mm-hmm.
They're going to be showing people, I think, sort of different maps of the clouds that JunoCam takes, and then they're going to ask people to vote on which images they'd like to take better resolution, more in-depth images of. And so the public will actually, this will be accessed through the Juno website at NASA. Starting in November, you can start voting for, like, oh yeah, that bit over there where there's this interesting brown stripe in the clouds. I think we should look at that. And it's not so much citizen science is something that's really important to NASA.
Mm-hmm.
And citizen science is when actually the public helps us analyze our data. And the idea is we need people to help us do this analysis. And the analysis is actually for a specific scientific goal. For example, at Hubble Space Telescope, there's an activity called Galaxy Zoo, where you help us classify the shapes of tiny little distant galaxies. I mean, only tiny because they're so far away. They're actually huge. But and we actually do statistics about the morphology of galaxies, how the shapes change over time, how the universe evolves. In the case of JunoCam, it's not so much citizen science as citizen involvement. We want people to feel like they have a voice in, what are we going to take pictures of? What do you like best? And obviously, whatever images come in, the planetary scientists will be pouring over them with bated breath, discovering new things all the time.
And not just the planetary scientists at NASA, planetary scientists all over the world. That's such a cool thing about a public institution like NASA, is that the data that's collected is freely shared with scientists and citizens alike.
In some ways, I've often sort of hoped that, like, world leaders would step up and say, don't you dare defund NASA, because I mean, when you think about what NASA does, there's obviously all the exploration of space and the planets, and all that is wonderful. And you're right. I mean, this helps support scientific inquiry all over the planet. I mean, we've done the statistics about how much of world science has some involvement of NASA data, and it's staggering. I mean, of course, like the majority of stuff does. But then there's the more close up and personal part, is that nobody is monitoring the climate of the Earth like NASA is.
Mm-hmm.
We have on the order of 20 satellites that are doing nothing but tracking things like the melt of the Greenland ice sheet, the change in the ocean currents, the change in the jet stream, air pollution levels. I mean, we're monitoring forest fires in the rainforests of Brazil, and then we've got a hotline to the Brazilian government if we actually see anything. I think that people don't really realize what a unique world treasure NASA is.
It's true. We think always of these instruments being trained outward. We have a good friend here in our core group that we call the Nerd Brigade, named Holly Bender. She was on the podcast quite a long time ago. It might be time to get her back on. And she's a JPL optics engineer. She makes optics for imaging spectrometers. We call her the mistress of space rainbows. And one of the I know, isn't it so good?
Very nice.
And one of the projects that she more recently worked on was just that, a spectrometer that went in a plane that flew overhead, that showed us more data about emissions from our own forests, from the trees that are growing here on Earth. To be able to get that kind of data, there's a whole climate science section. There's a whole climate science focus of NASA that, you're right, I don't think a lot of people realize is part of the overall mission of the organization.
Well, absolutely. And, even, there's climate change, and then there's something as simple as something like a hurricane,
Hmm.
where when there is a hurricane going on, I mean, NASA, of course, we have satellites like the Global Precipitation Measurement Satellite that has these special radar bands tuned to actually make a CAT scan, a 3D image of everything that's going on inside the hurricane. Then we actually
Cool.
we actually have drones. We actually have Global Hawk drones, the drones that are as big as a 737 as far as the wingspan, and
Hmm.
we fly those into the hurricane. And then we have people in human aircraft that are dropping probes into the hurricane. So, I mean, every time there's a hurricane, I mean, NASA's on it like three ways.
Wow, that's like a major improvement over the technology in that movie Twister.
Yeah,
I'm thinking
those are
back to
fun.
those
Yeah,
little, probes that they had to cut
and so it
out.
gets sucked up into the
Yeah.
tornado. Yeah, yeah,
They had to cut out the little Coke cans in order for it to fly. Wow, we've really stepped up our game, haven't we?
yeah.
That's really, really impressive. I have to say, I think it's so cool that you get to bridge that divide, that divide between the scientists who are really working hard every day, collecting data, analyzing data, creatively coming up with new ways to learn about our own planet and about, obviously, the cosmos beyond. And you get to help spread the message to the public that's so incredibly necessary. What's your favorite part of your job?
Well, it's like everything in life, things are complicated. I very much like what I do. There's always the little bit of me that has the imposter syndrome. I noticed that when I was being interviewed for Juno, they would say things like, "And here's planetary scientist Michelle Thaller." Well, I'm an astrophysicist actually, and I understand to the public that's not a big differential, but in my profession, that's huge.
Hmm.
And I'm always trying to gear how much I start slapping people down, saying, "Oh, no, 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 that's not my expertise. I don't really belong here." I mean, NASA didn't have this job. I thought that this was important. I thought
Hmm.
that somebody needed to tell the story, and I'm the one that kind of beat down the doors and said, "Hey, there's a place for me here. I think I belong here." And I've had to sell myself, and I've had to sell the idea that what I do is a useful thing to do. And it's there's always the struggle in myself. Did I fail as a scientist? Should I have been on more of a pure research track? Is it too arrogant of me to say, well, let me help you tell the story? I think that what I want to tell people out there is there are some absolutely wonderful jobs that are yours when you say, this is a skill I have. I don't see anybody else doing this. And I'd really like to try to make myself useful. But don't look at me and think that I don't constantly doubt whether that was the right path to take and whether I really am useful. So, it is a very interesting job. And it's also one that I've never completely gotten over the insecurities of either.
I have to say that that really strikes a chord with me. Probably the vast majority of people that I have on the podcast are science communicators first and foremost. That's what I consider my career trajectory. And again, you're right. Like many people who work in SciComm feel like they're sort of forging their own path because it's such a nascent field and it's such a field that a lot of people don't understand why it's necessary until they get the outcome of it. And I have so many friends who came from different places. I myself have a background in neuroscience, but didn't finish my PhD and before I switched gears. I have a lot of friends who did their PhDs and maybe even did postdocs before they decided to switch gears. And then I have, friends and colleagues who were journalists or have comms degrees or never even went to college who are now working as professional science communicators. And that imposter syndrome plagues anybody who's ever had a toe in academia.
Yes.
It's like it's so there for everybody, but you're right. It's such an important field and I think it's so wonderful to have the chance to talk to people who wear that hat in different areas, and to see that there are so many things I think that connect us, and there's so many things that we all sort of deal with. And I wouldn't be surprised if people listening to this show who don't work in science at all, who are purely just interested in the science but have other jobs, don't feel a little bit of that imposter syndrome as well in their chosen careers.
I think the idea that there's no way to be a scientist, there's no personality. I kept getting told all the way through my education that I didn't have the right personality to be a scientist, and the universe doesn't give a damn.
Yeah.
The universe doesn't care how we've culturally defined science. About who gets to do it. Do you need a doctorate? Do you not need a doctorate? I mean, you're okay the way you are. Your curiosity, your connection to the universe is worth just as much as anybody else's. And nothing needs to change for you to be a scientist. Just look up.
Oh my God, I love that so much. And you were featured, weren't you, in the PBS show, The Secret Lives of Scientists and Engineers?
Oh yes, that was pretty embarrassing. Yeah, I mean, I mean, no, I love dancing, and the Secret Life of Scientists and Engineers featured me doing my Renaissance dancing. The problem is the Renaissance dances are these intricate variations on mathematical patterns that my math brain just loves. But you do them with like 20 people. And when I was in the studio alone and I'm just kind of stepping around and just kind of hopping around, you don't really get the sense of what it's like. Your brain just goes, there's this incredible feeling of inclusion and
Mm.
concentration, and you just lose yourself when you and 20 other people are making these intricate patterns together. So, that was fun to do that, but I wish people could have had a sense of what those dances really were like.
I love that. So a good friend of mine, Crystal Dilworth, I've had her on the show. She also was featured in The Secret Life of Scientists and Engineers, and she also is a dancer. I love it when I find out how many people enjoy what we think of as the creative arts, the performing arts, who work in science and engineering. There's such a huge crossover because it's such a creative endeavor, and people don't generally think of science as being creative, but it absolutely is.
It's one of the big misconceptions about science. The idea that there is a true scientific process. We're all very soft and squishy and messy human beings, and it has so much to do with our hopes and our dreams and our imagination and our insecurities. And I let my scientific career be guided by who I want to work with. I only work
Mhm.
with people who are supportive, who feed me, who support me, who I love being with. And I've let that decide things like my PhD topic or where I took a postdoc or what my job path has been. There's all of that wrapped up in what people think is this logical and cold profession.
Mhm.
And it's just, that's a complete misconception.
So you open the door to it. So now I have to ask you, what was your PhD topic?
Well, it's interesting. So I could have done anything. I loved astronomy. I could have done, anything at all. And I had a wonderful advisor at college. His name was David Latham. And it turns out that he, in retrospect, probably found the first exoplanet. At the time, people didn't believe his data, but now he's actually sort of being recognized because it turns out that his data was correct. He actually had the right period, the right amplitude of this planet.
Oh, he was too
Um,
soon.
He's a little too soon, yeah, but
Yeah.
he was certainly involved in that. But he recommended this group. So I did my undergrad at Harvard, and he recommended this group that was doing really good, solid astrophysics. Not sexy, but what are stars really like? What can you learn about them? They mainly studied binary stars, and it was a
Mhm.
group at Georgia State University. And I went down there, and I found I had so much time to work with the professors. They were so supportive of me. They took me to the observatories all around the world. They introduced me to people at conferences. I just was so happy with the experience there. So I went from Harvard to Georgia State, and then I did a postdoc at Caltech. And in each case, it was who do I really enjoy working with?
I love that. And what were you focused on throughout that span?
Well, in my case, it was okay. So colliding winds in massive binary stars. Most of the stars in the sky are binary stars. They exist in pairs, and most of the really big hot stars that actually sort of drive the chemistry of the galaxy. All of the elements in your body come aside from the hydrogen, which was made in the Big Bang. Everything else in your body was made in a star that had to
Mhm.
fuse that atom and then die. And in the case of the really big stars, all of the things the iron in your blood, all of the gold in your jewelry. All of that comes from these massive stars. And these stars have these winds of high energy particles that actually collide and interact between the stars. And it affects the evolution of the stars, and it also affects the way the whole chemistry of the galaxy changes. And so I did a survey, one of the first surveys of these hot binary pairs, and tried to look and see what the shock waves were doing and how the shocks were behaving. And the fun thing is, when I look into the sky, there are still stars. Some of them, like the bottom star in the belt of Orion, is one of the systems I studied for my PhD. And I look up every time I see Orion. I look at that star, and and that's an old friend. I've spent nights and weeks observing that star. It's actually two stars, Delta Orionis. And all of a sudden, the night sky becomes your friends and your history, and you remember when you were young, and you remember going to Kitt Peak or Mount Stromlo, or wherever you did those observations. It's amazing what good company the sky becomes.
I love this. So basically, you're telling me that you studied the dynamic underpinnings of everything that makes up everything in the universe. Who we are, what
It's
everything we own
it's
is, everything around us.
the calcium in my teeth that I'm smiling right now. Like I said, the iron pumping through my veins, the tiny little bit of copper that my neurons need to function. You know, we are all these brief little collections of dead star material that exist for the blink of an eye, become briefly conscious, then scatter away. And I honestly don't know why we're just not all hugging each other in the streets.
When you were at Caltech, did you have a chance to go up to Mount Wilson?
Oh yeah, well the Mount Wilson people are some of my best friends. The Cara array, which is a stellar interferometer they run up at Mount Wilson, that was
Mhm.
actually the group I did my PhD with.
Oh, very cool. We went up there with some friends somewhat recently. It's been a few years now. We all pitched in because you can basically rent the 60-inch and it
Yep.
comes with,
Glad you did that. Yay!
yeah, like it comes with an operator. It's
Yep.
everything and somebody to like tell you or show you around. And we just spent all night observing and it was so stunning. I think before I got my telescope, I have a wonderful 8-inch computerized Schmidt Cassegrain that honestly, when I go out under dark skies, I can see things that are almost as brilliant as I saw at Mount Wilson. But up until Mount Wilson, I had never seen a globular cluster. I had never seen the Cassini division in the rings of Saturn. Like the
Yep.
things that we saw there just changed me.
Yeah, just be sure you do the same thing in the south. The southern sky is even better. But did you notice? I don't know if you happened to notice when you're at Mount Wilson that Mount Wilson is run by Georgia State University.
Oh, I
So,
didn't.
yep, yeah. So they run the Mount Wilson Institute.
Oh, that's
So
amazing.
yeah, once again, these are these absolutely solid workhorse astrophysicists up there that are just doing
Hmm.
brilliant work about how stars really function. I just they're wonderful.
I'll tell you what, I did notice Hubble's locker downstairs and
Oh
I took
yeah,
about 20 selfies with it. I was so excited.
yeah. It's amazing to think of the history of that place.
I know.
That's where they discovered the speed of light was constant.
Oh,
Think about everything that came out of that observation. The Michelson-Morley experiment, where they were trying to prove that. Well, they weren't expecting the result. They were trying to measure that the speed of light was different in one direction as the Earth went around the sun. And
hmm.
the weird answer they got was, nope, it's the same everywhere.
Wow.
Yeah. Ooh. I'm going to get back there. I am so going to rent the 60-inch or the 100-inch one night. I'm going to do that.
Oh my gosh, please let me know if you do.
Absolutely.
Let me know when you come to LA next because we have a really great network. Probably a lot of crossover since you spent so much time at Caltech, but
Yeah, I get to LA every couple of months. So I'll take you up on that.
excellent. Yeah, it'd be so much fun. So I have to ask you, this has been such a wonderful chat. I've learned so much. And I've taken, I think, enough of your Sunday away from you, but I end the podcast every time asking my guests the same two questions. And I'm absolutely thrilled to put you on the spot, first of all, and second of all, to hear your answers to them. So, and they're big picture, just to warn you. So I'll ask them both at the same time. Generally, I want to know first, we'll start with the one that's kind of more of a bummer. When you think about the future, in whatever context that's relevant right now, whether it's a personal context or whether we're thinking really globally and big picture, what is the thing that most concerns you, most worries you, keeps you up most at night? And on the flip side of that, what are you the most excited and optimistic for?
Well, okay. So there's, I mentioned NASA's study of climate change.
Mm-hmm.
And I don't think as a culture, as a global culture, we've really dealt with this at all yet. It's in 100 years' time. I mean, maybe not so much in our lifetime, but in our children's lifetime, in our grandchildren's lifetime, there are going to be some massive changes, and it doesn't have to be apocalyptic. But when I see how we're dealing with refugees now, a relatively small number of refugees,
Mm-hmm.
um, we're going to be dealing with something on the order of 1 billion refugees, and we've got to start talking about how are we going to handle this? How are we actually going to make this as peaceful as we can? Or are we just going to have a global war? And so the climate change is something that we've already bought to a large degree. There's certainly, if we make wise decisions now and we actually cut our carbon emissions and all things like that, there are definitely better scenarios versus worse scenarios. I mean, we need to
Mm-hmm.
take action, but things are going to change, and I don't get the idea that young people have really owned this as something that's going to become a major part of their lives. I mean, if in 100 years' time we're busy settling 1 billion refugees, are we going to think that an investment in a space program is worth it? When we have so many other problems to worry about, are we going to worry about the arts? Are we going to worry about science? I mean, I have some fear about us entering a very tumultuous period of history coming up.
Yeah, it seems like we have a pretty vague understanding, especially young people, millennials and later. I think there is this sort of existential threat that exists with most of us that we are living in the era of severe climate change. And I think there's also kind of a learned helplessness that maybe our leaders haven't taken significant action, and that's where you start to see this. I think this great swell. You've seen it with the Bernie Sanders movement lately, but this great swell of young people taking to the streets and hopefully taking to the polls to try to do something about it. But you're right; it does seem like when we think about the downstream effects of what is at this point inevitably happening, it feels very vague. Something like you just mentioned, having so many displaced refugees is not what's on people's minds when they think of climate change. They're thinking of hurricanes or they're thinking of the actual natural disasters, but they're not thinking about the effect that that's going to have on the people downstream and the fact that everything's, we're not going to be wiped out in one fell swoop. We're going to have to mitigate this stuff.
Exactly. We're gonna have to adapt to it, and we
Hmm.
can. I mean, that's the thing. So it's funny. I remember 2012. There was this internet rumor that the world was going to end to the Mayan
Oh,
apocalypse,
yeah.
whatever that was, and we were getting calls at NASA about it. In fact, we even set up a page at NASA that said there's nothing interesting happening in 2012 astronomically. We're all fine. But I would get these calls from people that would say, "So is the world going to end next week?" And I would say to them, and I would try to be polite, but after several of these calls, I'd say, "Do you think I'd be here? If my answer to you was yes, the world is going to end in a week, I'm at my desk at NASA. I'm actually working. That's how I would spend the last week of my life." And
Doing paperwork.
so I always say that if the scientists are all still going to work and they're all still functioning, don't be worried about anything. If all the scientists all of a sudden buy up all the good wine, max out their credit cards, and disappear, you know, then to be scared. And climate change is a little bit like that. At
Hmm.
cocktail parties, we sometimes talk about our zombie apocalypse plans. That when we retire, which for me will be like in about 20 years, um, where are you going to retire to? Because it's not going to be Florida. Where how are you going to invest your money, because things might start to get unstable.
Hmm.
We're starting to make our plans for what if things actually really do start to go south. And I think when scientists start talking like that, that's when you got to get worried.
Yeah, yeah.
Okay,
So
onto the good
I know
stuff. All
I'm
right,
like, okay,
yeah,
huh, big breath. Moving on, moving
yeah, even
on.
better.
What are you excited about?
Oh, there's so much to be optimistic about. I mean, as you mentioned, we're in this golden age of discovery, but it's in fits and starts, and this has been a bad week for thinking about diversity and how our
Yeah.
culture is accepting people of color and different genders and different sexualities. But I love the fact that NASA has a float in the Gay Pride Parade, and I love it that we have transgender scientists, and it doesn't matter. And I love it that as a woman, I can get pissed off and say, where are the women in this meeting? Where are the women in our
Mm-hmm.
upper management? Where are the people of color? Why don't we look like the general population? Um, just 20, 30 years ago, NASA wasn't very diverse at all. The only people
Yeah.
who ever walked on the moon were white guys. So I think what I'm allowed to be angry about and what I'm allowed to believe about myself and what I'm allowed to think has to change, and how I can demand and say, look, I am a legitimate full human being. I'm nothing less. Do not tell me that because I'm a woman I am this way or I will respond this way. I've actually I've been made very angry at diversity trainings. People mean well, but
Mm-hmm.
there'll be like a guy leading a diversity training, and he'll say, well, women are very they're not very aggressive. They want to be included. They'll be very quiet. So if you want a woman in your group, you have to be aware of this. And I'm sitting there in the back going, hell no. I'm going to climb up your butt if you say that. I'm there's nothing about me that's retiring and reclusive and gentle that way. And I'm allowed to say the way I am is absolutely fine. And so I think that's changing in our culture in fits and starts. And I'm very much heartened by the power we're going to have if we start not denying most of humanity a real solid role in science and in the culture in general.
It's just so true that if you take a microscope to what's been happening lately, if you take a small sliver of time, a small cross section of time, you can very easily get discouraged and get very depressed. I mean, like you said, this last week has been especially difficult. But if you do widen your field of view just a little, take a little bit of a step back, you will see that we're on a trajectory that is a really positive one. It's really depressing when we take two steps backward when it comes to progress, but the truth of the matter is the world is open to us in a way. The world is open to women. The world is open to people of color. The world is open to, like you said, the LGBTQ community in a way that it never was before. And I'm very excited by that as well. And I'm so glad that that was your answer to that question, because especially right now, it's so timely and so important.
As I said, the universe doesn't care what your personality is. The universe doesn't care about your gender, the color of your skin, your sexual orientation. We are all the same thing, all looking out with 7 billion sets of eyes, and we're all so brief. Just, I'm sorry, I definitely have existential angst.
Hmm.
So soon I won't exist, and we have this one time to look up together, and I think we just really need to take it.
On that note, Michelle, thank you so much for joining me this week on the podcast. It was an absolute pleasure. Can you let everybody know where they can, find you on social media, where they can see more of the great outreach that you're doing?
Well, as far as the outreach, definitely just go to nasa.gov. You'll see all the latest stuff on NASA. As far as me personally, I'm on Twitter at ML Thaller. Facebook, you can find me, Michelle Thaller. And I'm doing Snapchat a little bit when I have a bit of time. But yeah, those are probably the easiest places to find me, is the Facebook and Twitter stuff.
Nice. Well, once again, Michelle, thank you so much for joining me.
It was a pleasure. Thank you so much for having me.
Of course. And everyone listening, thank you for coming back week after week. I'm really looking forward to the next time we all get together to talk nerdy.